Let's lift the veil of mystery. In 2014, NASA began work on a revolutionary unmanned vehicle, the Mars helicopter Ingenuity. This unique project was developed to test the possibilities of flight in Mars' thin atmosphere, not just to adapt to existing conditions. Engineers and scientists enthusiastically searched for new ways to explore the red planet, focusing on the possibility of autonomous flight in such extreme conditions. The advantages were clear: lightweight and durable materials, innovative autonomous control systems, and advanced power supply technologies formed the foundation for a craft weighing about 1.5 to 2 kilograms. Ingenuity became a technology demonstrator, paving the way for future space missions rather than responding to commercial challenges in global aviation. Of course, the success of such a project was made possible by the evolution of technology. Mobile Snapdragon processors, ultra-lightweight batteries, they all played their part. Was it any wonder that 2017 became a landmark year in the development of these technologies? Taking things a step further, Ingenuity began to explore the boundaries of what was possible, opening up new horizons not only on Mars, but for all of humanity's future missions. So, what drives the success of such projects? It's not just competition in the field of new scientific concepts, but also the drive to stay one step ahead of traditional approaches. Ahead, we will hear stories about those who brought this project to life and how it could influence the further exploration of space and beyond. The team of engineers. The project to create a helicopter aimed at revolutionizing our understanding of aviation became possible thanks to a unique team of specialists. By implementing innovative ideas, a group of engineers and scientists with vast experience in the aerospace industry and aerodynamics demonstrated how years of expertise can be the key to innovation. At the forefront of the development were aeronautical engineers, computer engineers, and environmental specialists. Their interdisciplinary approach turned out to be exactly what was needed to overcome all the challenges on the path to creating a next-generation aircraft. They worked tirelessly on improving the helicopter's aerodynamic characteristics and functional capabilities, developing every aspect of it with superhuman dedication. Writing programs for simulating airflows and creating digital prototypes, these were the tools professionals used for repeated engineering calculations and testing. Working in a high-tech environment became the norm for this team, each member contributing something to the development, from mathematical models to improved navigation. The stakes are high. All the results of calculations and tests are aimed not just at achieving a new design, but at creating a safe, highly efficient machine capable of withstanding any complexity of flight. These specialists are ready to challenge traditional conventions and present the world with an idea that will define the future of aviation. Their efforts seem limitless, and the next frontier of technological breakthroughs is already in sight, promising to add even more features and capabilities to our dream helicopter. Technological breakthroughs. Imagine if a helicopter could change its capabilities with a single turn. This is precisely the principle behind the concept of tilt rotors, such as the V-22 Osprey. In our project, the concept of using variable pitch rotors has been updated to achieve greater maneuverability and efficiency. These devices, by providing improved adaptation to different flight conditions, become a key technological aspect. Now, a bit about materials. Imagine the lightness and strength embodied in next-generation composites. Take, for example, ultra-light carbon fibers or reinforced polymers. These materials directly contribute to reducing the unit's weight, increasing its efficiency and reliability. This is not just a trend, but a technological leap that is changing the face of modern aviation. Our helicopter is also equipped with advanced autonomous control systems, which are being developed in a number of projects, including the S-97 Raider by Sikorsky. Thanks to the integration of machine learning algorithms, this aircraft is capable of making real-time decisions, increasing both the safety and range of autonomous flights. It is precisely hybrid technologies and autonomy that make it possible to significantly expand the horizons of flight range and functionality. Imagine how gyro-stabilized flying vehicles with unique stabilization mechanisms can provide unprecedented maneuverability and safety, shattering conventional notions of what aviation can do. And this is only the beginning. It has already been tested how these technologies cope with the challenges of reality. What tests will help us see whether they live up to our expectations? We are on the threshold of new possibilities. The testing and trials of our revolutionary helicopter are conducted at specially equipped ranges designed for testing new aviation technologies. And although this may sound like a step closer to science fiction, note that all tests are carried out with high precision and in compliance with standards. Imagine high-speed rotor spinning, not breaking apart but working in perfect harmony as they test their limits. It is equipped with advanced sensor systems that transmit real-time data to a special command center where specialists analyze it. This helps engineers monitor any deviations and respond quickly to potential issues. The initial flights focus on basic maneuvers to test controllability and stability. Once these tasks are completed, we move on to more complex tests under various conditions, including those that simulate extreme weather anomalies or unexpected situations. An important aspect of the test is the use of simulators and digital twins, which make it possible to predict and prevent potential failures before they actually occur. These digital models mean a great deal to the research team, as they allow them to interactively review hundreds of testing scenarios without any real risk. The results of the test provide insight into what design changes are necessary to improve the performance and increase the safety of the device. Here, our engineers modify and refine the design, turning theoretical calculations into practical steps. Testing work only opens our eyes to limitless possibilities. After all, the higher the bar for testing, the more amazing our future in aviation becomes. Impact on aviation. The aviation industry is changing rapidly, and at its very core are projects developed with a focus on ecology and innovation. NASA's new developments, although not aimed at an instant revolution, still contain important directions for progress that could change our perception of helicopter engineering. Engineers are focusing on implementing hybrid and electric engines, which makes it possible to significantly reduce the harmful impact on the environment and noise levels. Imagine lightweight materials, such as the use of carbon fiber and the latest autonomous control systems, which are already becoming an integral part of modern aircraft. These prospects will form the foundation for aircraft in the coming years, starting from the first quarter of the 21st century and beyond. NASA's developments in improving control systems and introducing new materials will provide a solid foundation for the adoption of other innovations. The introduction of new technologies is also opening up new business models in aviation. Electrification and the use of biofuels represent important steps toward decades in which every flight will leave a minimal carbon footprint. Even today, companies are actively restructuring to keep up with the integration of these breakthroughs. And although helicopters are not the main players in intercontinental transportation, their ability to become more environmentally friendly will disrupt established norms. Self-learning and intelligent systems integrate advanced algorithms that enable aircraft to operate in the most extreme conditions. Technologies developed in the drone and light helicopter segment are gradually being recognized and adopted in larger aviation projects as well. The time is not far off when the interaction of eco-friendly materials and autonomous technologies in aviation will become commonplace. Innovations that today seem like mere hypotheses will define our future tomorrow. Have you ever wondered what other aerial marvels await us ahead? Applications in civilian life. Modern helicopters are on the verge of a revolution in transportation. These machines are capable of reaching places where neither trucks nor airplanes can manage. They could become the next chapter in the evolution of logistics and delivery. Although for now these are just concepts and pilot projects, the persistence of engineers and technologists is leading to real achievements. At present, helicopters are still used for experimental and specialized tasks. Their maneuverability allows them to respond instantly to emergencies, from medical aid to rescue operations. The limitations remain the whims of the weather and the considerable cost of operation. But the potential of these machines is enormous. Of course, helicopters can deliver cargo faster than ground transport, especially in densely populated megacities or regions where the roads leave much to be desired. However, speed depends on many factors such as weather conditions or the length of the route. Logistics companies are increasingly interested in these innovations, which bring flexibility and efficiency. We must not forget that helicopters were originally designed for military purposes, but today they are becoming key elements in civilian tasks. Their history is evolving, and new opportunities are on the horizon. Helicopters equipped with lightweight materials and advanced electronics continue to evolve, but for now they remain quite expensive to operate. This does not stop the growing interest in experimental projects that aim to integrate such machines into everyday business. The future of civil aircraft is tied to the development of electric and hybrid models, paving the way for more sustainable and responsible aviation. These ideas promise us a new generation of helicopters, ready to impress not only with their technology but also with their environmental awareness. And how these changes will affect the environment is something we'll discuss in the next stage of our deep dive into the world of aviation innovations. Environmental aspects. When it comes to aviation and the environment, NASA is at the forefront of innovation. Among the many projects they are working on, significant attention is given to the development of environmentally friendly aviation technologies, including hybrid and electric engines for various types of aircraft. It's important to understand that aviation is responsible for about 2.5% of global greenhouse gas emissions, but its impact on the environment is more pronounced due to emissions at high altitudes. New technologies are not limited to engines alone. Carbon fibers and composites make it possible to create lighter structures, which in turn reduces fuel consumption and lessens the environmental impact. These materials have already become standard in the aviation world, strengthening its sustainable development. Nevertheless, full electrification of large aircraft is not yet practical due to the weight of current batteries. The transition to more environmentally friendly technologies requires the development of appropriate infrastructure. Imagine cities where flying taxis and drones become part of everyday life. This will require large-scale changes to power grids and charging stations. This is a long-term challenge that demands coordinated efforts from all participants, from scientists and engineers to government authorities and society as a whole. Despite the long road ahead, the prospects of NASA's experiments are encouraging. They aim to find solutions that will pave the way for a new era of aviation, where flights are not only efficient but also minimally harmful to the planet. Of course, these changes won't happen overnight, but steps in the right direction are already being taken. Will we find out what kind of future awaits our world with the adoption of these innovations? Time will tell. And ahead of us lies the exploration of potential breakthroughs in aviation technologies. Development prospects. Imagine a future where helicopters using advanced battery technologies will completely change our understanding of air mobility. Already in the next few years, by the middle of the 22nd decade, active research and testing of batteries for electric and hybrid helicopters promise to increase their flight range and autonomy, reduce operating costs, and minimize carbon dioxide emissions. Although widespread adoption may take more time, individual commercial models confirm the high potential. At the same time, robotics and AI are actively being integrated into helicopter control systems. Autonomous and semi-autonomous systems are already appearing on test platforms, enabling the execution of complex tasks even in the most challenging conditions. However, full self-governance remains at the stage of evaluation and prototyping for now, but its development promises to radically change our understanding of aviation. Let's also talk about materials. The use of modern composite solutions, such as carbon fiber, leads to significant improvements in aerodynamics. Helicopters are becoming lighter, stronger, and capable of reaching speeds far exceeding those of traditional models. For example, thanks to the collaboration between Sikorsky and Boeing on the SB-1 Defiant project, speeds of around 400 kilometers per hour are being achieved. Environmental standards are also not being left behind. Fully electric and hybrid helicopters are no longer just a fantasy, but a development reality ready to reduce aviation's carbon footprint and noise pollution. However, for widespread adoption, further breakthroughs are needed both in battery technology and in the creation of infrastructure. Let's also highlight important Russian achievements. At the Heli Russia exhibition in 2025, the Moscow Aviation Institute presented the Universal Unmanned F-1 device, which became a breakthrough in the field of modular flying systems. Additionally, the Dandelion drones from Atrium JSC demonstrate successful progress in the direction of unmanned systems. The curator of these projects, Boris Borisovich Sofoklov, heads the research department of the 104th Institute of Aviation Technology at MAI. The updated Mi-26, with composite elements and improved engines, increases efficiency, allowing it to fly even in Arctic conditions. What other amazing discoveries will the future of aviation bring us thanks to the development of these technologies? Very soon, we will find ourselves one step closer to solving this question. Corporate secrets. An interesting fact, in the 70s, NASA developed the first fully electric test aircraft, which became the predecessor of modern drones. Although the agency's attention is now focused on space, their experiments in the field of aviation technology continue. The topic of protecting developments at NASA is an incredibly important part of how the agency maintains its leadership in innovation. When it comes to protecting intellectual property, NASA uses a comprehensive approach. This includes patents that guarantee copyrights and innovations, as well as a finely tuned security control process. As a government agency, NASA follows strict federal standards, complying with all necessary regulations and confidentiality agreements. These measures make it significantly more difficult to violate rights in the highly competitive aviation industry. But the protection doesn't end there. Within the agency, access to key project components is strictly monitored. Dividing information between departments helps minimize the risk of leaks. In addition, working groups create separate digital environments where calculations and modeling are carried out, making the project safe for the development of new unmanned systems. Among NASA's partners are renowned players in the aerospace industry. These partnerships allow companies to use the results of joint research in a safe and beneficial way. Mutually beneficial exchange of data and resources leads to new prospects in the development of aviation technologies. Thus, NASA continues to evolve, not only protecting its developments but also advancing them into the future. The security system enables the agency to remain at the forefront of scientific discoveries. How they plan to further develop their aviation initiatives remains an intriguing question. Collaboration with the military. It is worth noting that although NASA does not directly engage in the development and production of military helicopters, many technologies born within the agency have found and continue to find their application in the defense industry. NASA reports that aerodynamic research, experimental projects, and developments in material science form the foundation for technologies that are later adapted for military needs by individual contractors. For example, let's look at projects focused on developing technologies that could provide quieter and more efficient rotor operation. These can be applied in helicopters developed for military purposes. In this context, NASA acts as a catalyst for new discoveries, which are then processed and advanced within military circles. The Pentagon and agencies like DARPA are actively conducting research and testing in the field of rotary wing aircraft, such as the V-280 Valor, and are working on creating faster, longer range, and more maneuverable aerial vehicles. This Army initiative is aimed at replacing outdated aircraft such as the Black Hawk and Apache, which are scheduled to take to the skies in the 2030s. Of course, the potential use of autonomous systems and stealth remains a top priority for military departments and scientific organizations, but this is primarily the responsibility of the Pentagon and DARPA. Nevertheless, the sensor technologies and autonomous control systems developed by NASA for the civilian sector are finding their place in the broader aviation ecosystem, providing more opportunities for research facilities and increasing their efficiency. Thus, while NASA's technological threads may intertwine with military developments in an indirect way, in the vast world of innovation, the roles and contributions of each organization can be multifaceted and surprisingly interconnected. We will leave the intrigue of further scientific progress for the future, when we will see how it will impact the development of the global aviation industry. The reaction of the international community. NASA's impressive achievements in space technology consistently attract global attention, and a helicopter project like the Martian Ingenuity becomes part of the paradigm of these innovations. Ingenuity, as the first aircraft to achieve controlled flight on another planet, has become a source of inspiration and sparked worldwide interest in its potential impact. Although the agency's main focus is on space, a revolutionary development like Ingenuity draws attention to the potential for applying these technologies in a wide range of fields, including aviation. International partners, such as the European Space Agency and the space agencies of Canada and Japan, are closely following the fate of this project, paying special attention to opportunities for sharing knowledge and technology for future space and aviation missions. Interestingly, these innovations may also spur international efforts toward environmentally friendly technologies, although the main exchange between NASA and other countries remains in the field of space research. Collaboration with international partners, especially in the context of space exploration programs, confirms the recognition of US and NASA leadership on the international stage in the field of aerospace science. Naturally, in the global technological race, every achievement elicits a wide range of reactions, from admiration in allied countries to challenges from competitor states. China and Russia, for example, closely monitor NASA's achievements, which stimulates their own programs and intensifies global competition in the scientific and technological sphere. It is important to note that it is precisely space technologies that form the foundation for such large-scale international cooperation, leading to memorable projects. Apparently, the flexibility and adaptability of aerospace technologies will continue to strengthen NASA's role as a leader, setting the tone for the global scientific agenda in the future. With every step forward, new horizons of cooperation await us, where grand plans inspire excitement within the scientific community around the world. The future of flying vehicles. Imagine a future where every day the sky comes alive with the sound of new flying vehicles. NASA, along with other innovators, is constantly exploring technologies that could change everything. The electric and hybrid eVTOL vehicles being developed by the agency promise to usher in the future of air mobility. Like most industry leaders, NASA has tested the electric propulsion power of the X-57 Maxwell, demonstrating the viability of new technologies. These steps are not a unique initiative of a single agency, but part of a global movement that is gaining momentum. Hybrid systems have already demonstrated their significance on the path to sustainable aviation. Just imagine, small vehicles are capable of covering a couple of 100 miles with minimal impact on the environment. However, fully electric intercontinental giants are not yet on the horizon. These tasks are currently handled by traditional jet engines, with hopes for hybridization in the future. Autonomous control technologies are already being tested, but a complete replacement of pilots is still only in the planning stages. At the same time, autopilots promise increased safety and a reduction in human error, which also cannot be ignored. Research and development continue in the field of aerodynamics and materials. Lightweight composite designs are more important than ever for improving maneuverability and efficiency. Speaking of range, urban air taxis and light aircraft are fully ready to take their place in the city, covering short distances in a short amount of time. On longer routes, traditional airliners still dominate, preparing to adapt hybrid technologies closer to the end of this decade. All these steps are part of a long journey, but they are our future. These rapid breakthroughs are what turn the energy of tomorrow into a powerful driving force, from Martian exploration to everyday transportation, promising to open up even more horizons in the world of aviation. Are you ready to become part of this exciting journey? All that remains is to wait and watch as these innovations become reality.